All right, so for estimating square roots, this is when our square roots are not from a perfect square, okay, when they're irrational. So anything that is not 1, 4, 9, things that are perfect squares that we just worked with, these are going to be the non-repeating, non-terminating decimals. Now we can punch them into our calculator and get numbers out, but it is important that we know how to estimate them. So there's two ways to estimate them. Let's look at the square root of 2 as our example. 2 is not a perfect square, so we need to use an estimate if we aren't going to use a calculator. And yes, there will be times I ask you to estimate. To estimate, the first way, this is our quick and dirty way. We're going to find two perfect squares, one that is smaller than our number and one that is larger than our number. For square root of 2, the next smallest perfect square would be square root of 1. The next largest perfect square would be 4, so square root of 4. So we know that square root of 2 is going to be greater than 1, because that's the square root of 1, and less than 2, square root of 2. Notice we're just using our principal square roots, so just the positives. This means that the square root of 2 is approximately equal to 1.5. And at this point we can add our plus and our minus because it is a square. Now you try. Use the same method, find two perfect squares, and find an estimate of square root of 6, and also find an estimate of the square root of 31. Pause the video and give that a try. Alright, now let's say we need to find a better estimate, which in an example later we're going to have to. We've already done our first estimate. We found that the square root of 2 was about equal to 1.5, but say I want to know it to more than just one decimal place. Well, what I do, here's my initial estimate, 1.5. So I'm going to take numbers close to 1.5 and I'm going to square them. So I've chosen 1.3 and I square it, that gives me 1.69. I've chosen 1.4 and squared it, and that gives me 1.96. And then of course 1.5, when I square it, gives me 2.25. So when I look at these three answers, I notice that 2 is greater than 1.96, which is 1.4 squared, and it's less than 2.25, which is 1.5 squared. So the better estimate for 2 would be in between 1.4 and 1.5. So we could estimate it as 1.45. These are both perfectly good estimates, but this one is better. Now you try to get a better estimate, meaning estimate to the hundredths place for the ones we just did. Square root of 6 and square root of 31. Pause the video and give that a try. Now once you can estimate the values, then you can start to compare, oh dear, and order the numbers. Sorry about that. Aha, better. And order the numbers. So let's take this example. The square root of 3 plus 5, and 3 plus the square root of 5. And the question is, I want to know, is this greater than this? Is it less than, or is it equal to? So the first thing I do is I estimate. So my square root of 3, I can estimate between 1 and 2, because that's going to still be between the square root of 1 and the square root of 4. So it's going to be approximately equal to 1.5. All right, so now 1.5 plus 5, well, this side is approximately equal to 6.5. On this side, my square root of 5, I know is going to be in between 2 and 3, because the square root of 5 would be in between the square root of 4 and the square root of 9. So I'm approximately at about 2.5. So if I add 3 to 2.5, I get approximately 5.5. So this side, 6.5, is greater than 5.5. So this side is going to be greater than this side. Notice again, what roots am I using? I'm using principal roots. Now let's look at this one. So if I have the square root of 10 plus 2, and I want to compare that to 10 plus the square root of 2, I can estimate my square root of 10 as being in between 3 and 4, because square root of 10 would be in between square root of 9 and the square root of 16. So that's going to be approximately 3.5, because that's in between 3 and 4. 3.5 plus 2, it's going to be 5.5. Over here, I've got the square root of 2, which we've already estimated this way to be 1.5. 10 plus 1.5 is 11.5. So therefore, my estimations let me know that this side is less than this side. So you go ahead and try this ratio. Is this greater than, equal to, or less than the other side? Pause the video and give that a try. The other thing you can do is you can order from least to greatest. Let's say that I'm given three numbers, square root of 3, pi, and 1.5. And I have to put them in order of least to greatest. So I need to estimate my 1.3. So I'm going to do my initial estimation. So here we go. Well, square root of 3 is going to be in between square root of 1 and square root of 4. So it's going to be between 1 and 2. My initial estimate would be about 1.5. But I need better than that. Why do I need better? I already have 1.5 right here. Okay, so I need to get to the next place. So now I need to do that second round of estimation. So I started here at 1.4. 1.4 squared was 1.96. 1.5 squared was 2.25. And so I had to keep going. 1.6 squared was 2.56. Still had to keep going. 1.7 squared was 2.89. And my last row was 1.8 squared, which is 3.24. Notice, I keep going until my answer is bigger than the number I'm taking the square root of. So since 3 is in between 2.89 and 3.24, a better estimate of square root of 3 would be in between 1.7 and 1.8, or 1.75. Now pi is an irrational number, and we can estimate it as 3.43. So when I rate these, my 1.5, my irrational number here, is actually the smallest, which is smaller than 1.75, which is smaller than 3.43. So my answer would be 1.5 is less than square root of 3, which is less than pi. Now you try this. Go ahead and order these three numbers. See how you do.